Hello and welcome to my correction of exam of the module 4. I'm going to start by correcting exercise number 2, which says the base formula of the natural exponential function is, and the answer that I selected was A, which is A, but this is incorrect since natural exponential functions are always equal to E, Euler's number, because of their nature, because they are not logarithms of base 10 or any other base, meaning that the arrows are going to be equal to E. Now in exercise number 4, which says change the logarithm expression to the equivalent expression involving an exponent. The function is natural logarithm of x equal to 2. Now, since we know that natural logarithms are always equal to E, we can express the function as e to the power of 2 equals to x. Now, the answer that I selected was x to the power of 2 equal to e. Now, this is incorrect since what the natural logarithm is telling us is that the exponent that we are looking for is actually equal to 2. And x is telling us what the operation is. Moving on to exercise number 8, which says write the sum and or the difference of logarithms, express powers as factors. So what we need to do here is to take down our expression into different logarithms. We shall not do anything besides that. The expression that they are giving us is logarithm base w in brackets 9x over 2. That would be equal to the whole expression divided into different logarithms. We can actually do this by taking down the divisions as differences and the multiplications as additions. So the answer would be logarithm base w 9 plus logarithm base w x minus logarithm base w 2. Moving on to exercise number 12. It says, solve the exponential function. Express the solutions set in terms of natural logarithms and as decimal rounded to 3 decimal places. So what we need to do here is to take down our expression into factors and that we can actually calculate x, we can solve for x. The expression given is e to the power of x plus 7 equal to 2. So what we need to do here is first take down the exponent. Since e is what is being elevated into a power, we can take it into a logarithm, meaning that logarithm of x plus 7 is equal to 2. Since we already know what the properties of natural logarithms are, we can actually take that natural logarithm and the 2 that is outside the equation as e to the power of 2. So e to the power of 2 would be equal to x plus 7. So then what we need to do is to extract x from that equation, meaning that x would be equal to 7 plus e to the power of 2, meaning that x is equal in decimal values to 1.389. Moving on to exercise 13, it says, solve the equation. Express irrational answers in exact form and as decimal rounded to 3 decimal places. The expression or the equation that they are giving us is 4 elevated to x is equal to 3 elevated to 1 minus x. What we need to do here is first convert all of them into natural logarithms, since they are in the exponent of the bases. So the expression would be equal to x natural logarithm of 4 equal to, in brackets, 1 minus x natural logarithm of 3. Since the 1 minus x is in brackets, we can actually take it down into 2 natural logarithms, meaning that x natural logarithm of 4 would be equal to 1 natural logarithm of 3 minus x natural logarithm of 3. Then what we need to do is to take away the x's so that we can solve for x, meaning that x multiplying natural logarithm of 4 plus natural logarithm of 3 would be equal to natural logarithm of 3. Since we need to solve for x, we need to pass away the natural logarithm of 4 plus natural logarithm of 3 into a division, meaning that x will be equal to natural logarithm of 3 divided by natural logarithm of 4 plus natural logarithm of 3. That would give us an exact answer of a decimal answer of 0.4421. Moving on to the last exercise, which is a graph from module 1. It says, answer the following radical function. A, horizontal asymptote 1 point. B, y-intercept. C, domain. D, coordinate of the whole, if any. Vertical asymptotes and the x-intercepts, then graph the function. So this is the graph of the function, and what we need to do first is to factorize all the equation so that we can solve for any holes that there might be. So the expression that they are giving us is x to the power of 2 plus x minus 2 divided by x to the power of 2 minus x minus 6. So when we factorize it, it says x plus 2 multiplied by x minus 1 divided by x plus 2 multiplied by x minus 3. So looking out at the bottom part of the fraction, we can actually calculate the x asymptotes, and in the upper part we can calculate the y asymptotes. But if we pay attention, x plus 2 is both in the upper and lower part of the equation, meaning that there's a hole in the equation. So the graph that we are going to have is going to be a really simple graph that only has one asymptote per axis, meaning that the x asymptote will be equal to 3 and the y asymptote will be equal to 1. So we can actually calculate the intercepts very easily only by taking x as 0, and that way we can actually calculate the y-intercept would be equal to 0, 1/3. And to calculate the x asymptote, we actually need to look at the upper part of the equation, and since there's a minus 1, we actually need to pass that into positive, so the x asymptote will be equal to x equal to 1. And last but not least, we need to calculate the holes, the domain, and the range of the graph. To calculate the holes is actually really simple. We just need to replace x in the equation with the value of the term that we eliminated, which was x plus 2. So that actually converts into a minus 2. So what we need to do is replace the x's with a minus 2 in the equation. That would give us the answer of 0.6. That way, the coordinate of the whole is minus 2, 0.6. The domain, it is actually very simple. It is the whole of the real number range, only with the exception of 3, because that is an asymptote. Meaning that if we actually solve the equation with a 3, then we will have an undefined answer. The range is the same, so the range would be y such that y is different from 1. Thanks for watching.